right, let's do this one more time. Number 16. This function just looks pretty wild, doesn't it? Okay, well, it's a fifth degree function, which makes it quintic. And then it has 1, 2, 3, 4, 5 terms, so it's a quintic polynomial. If you wanted to be a little more specific, you could say it's a quintic polynomial with 5 terms. We'll just leave it at that. We can call it Clyde. Yeah, we want to know the range and the domain for Clyde. So the x values, there is no limit to those. Domain is all real numbers. What about the range? If you look at this end and this end, you see that this function goes down forever and up forever, so it has no limit to its y values. The lowest y value you could imagine will exist for this function, so negative infinity all the way to positive infinity. That's what all reals is entailing there. Okay, so for the end behavior, if we look on the left side at that left arrow, you see it points to the left and it also points down. That means the x values are going in the negative direction forever, and the y values are also going in the negative direction forever. So down is the negative y direction, left is the negative x direction. Did I say down is the negative y direction? I don't know. We'll have to go to the footage. On the right side, this arrow, or this is pointing up, and it's also pointing to the right. Okay, so as x values go to the right, they get bigger and bigger. They go to positive infinity, and y values are also going to positive infinity. Let's knock out the y-intercept while we're here. We'll come back for x-intercepts and extrema and all that. Okay, look at the equation. The equation, when it's in standard form, will tell you the y-intercept. When you graph the function, you can also find the y-intercept in the table, but it's really easy to find from the equation. It's the constant term. Where's the constant term? Usually comes after the linear term, right? Well, what's over here? Bunch of nothing. That means that the y-intercept is 0, 0. All right, that means that also an x-intercept would be 0, 0, right? Because if that's where it crosses the y-axis, it's also crossing the x-axis there. So those are both an x-intercept. It's both an x-intercept and a y-intercept. All right, let's go ahead and find the rest of those x-intercepts. So I've already typed in this function, and I'm going to hit the button that says graph so that it will graph that function. You can see there's a point here that's a maximum, there's a minimum over here. 1 0, 2 zeros, 3 zeros, 4 zeros, 5 zeros. Makes sense because it's a fifth degree function. This is going to have at least 5 zeros, and these all happen to be real. Okay, but we just want to find all those zeros. So I can change the window right now, and I will do that. My window doesn't go quite high enough, and it also doesn't go low enough. So I'm going to change both the y minimum and the maximum. And now it goes high enough, but I still don't get the bottom of this. So I need to change the window a little bit more. The y minimum, negative 40, maybe that'll work. Yeah, there we go. So now I can see everything. I want to know these points, and I already found the middle one. So second, trace. I'm going to find a 0. And I'm going to go way over here to the left. The left side, there's a little delicacy to this one here because there's not a whole lot of room between those zeros. Okay, so I'm going to get the one on the far left first. I need to get on the left side of it. Check. Now I'm on the left side. I'll hit enter. Now I go to the right side, but be careful not to pass the other 0. Okay, so I'm on the right side of it now, and I haven't gotten to the other 0 yet. That's where I want to be. Hit enter, and it finds it. Negative 3, 0. Oh, I forgot to mention, if you hit second and graph and look at the table here, you may accidentally find some zeros if they're nice integer values. Negative 3, 0, 0, 0, and 2, 0. We have all of those. Negative 3, 0, 0, 0, and 2, 0. Okay, so I'm still missing 2 zeros. I will find them both right quick. Second, trace. I want another 0. Okay, I'm looking for this one just above this cursor, so I got to get to the left side of it. But I don't want to go so far that I pass this other 0 right here. Okay, so I'll hit enter once again. Then I'll go to the right side of that 0, and I'll hit enter again. One last time, negative 2.6, comma 0. Negative 2.60, and one more. That one is also 2.60. And you can find it same way I just found the other one. Now let's find the extreme values. We have 1, 2, 3, and 4. Very common for a fifth degree function to have 4 extreme values. That means there are 4 moments where it starts increasing, then it hits a maximum, starts decreasing, hits a minimum, starts increasing again, hits a maximum, starts decreasing, hits a minimum, starts increasing. Before we can do those intervals, we need to know those points, the maximums and minimums. So calculate. Second, trace. I want to know a maximum. That first one is a maximum point. Is it local or is it global? Does the function ever go above this point? Sure does. Right there, right there, right there, right there, right there, right there. So this is only a local maximum. But it is a maximum because it stops increasing and starts decreasing. My cursor's on the left side of it, so I'll hit enter. Now my cursor's on the right side, so I'll hit enter. Negative 2.8, 2.3, negative 2.8, comma 2.3. That's a local maximum. Let's go find another one. Second trace. Again, this time I want a minimum. I'm going to go to the next one. Whoops. Second trace. I want a minimum. So I'm looking for this point down here. Get on the left side of it, hit enter, right side, enter twice, negative 1.3, negative 38.7, negative 1.3, negative 38.7, and that's a local minimum. Because the function does go below this point, this whole part is below that point. So just locally, that's a minimum. Just like this one's going to be local. Okay, I'm going to pause, do a little bit of TV magic, and find the other maximum and minimum, and then we'll do interval. All right, so I've got them now. We can do intervals increasing and intervals decreasing. I'll change colors for this. Let's go with purple. That's a great color. Okay, so how does this function begin? Coming in from negative infinity, we read it like a book, left to right. As soon as we hit this, we see it was increasing. So our first interval starts with negative infinity, and we're increasing. And when does it stop increasing? Remember, here's our options. We can use these numbers. Those are the only numbers that should appear in our intervals because those are the x values at the extreme points. And those are the significance of those extreme points in part is that that's where they stop increasing and start decreasing, or stop decreasing and start increasing. So this first point is negative 2.8. Then it stops increasing and starts increasing, or starts decreasing. Whoops. At negative 2.8. And when does it stop decreasing? At the local minimum point, negative 1.3. Then it starts increasing again. From x equals negative 1.3 until x equals 0.97. This function is increasing again. Then it starts decreasing, 0.97, until when? Till this minimum point, when x equals 2.4. And then it starts to increase again, 2.4. And when does it stop increasing? Well, that's the last maximum point, and so it increases forever. All right, and before I sign off, I'll just point out, again, the domain is all reals. So the bookends for the intervals are negative and positive infinity, and in between you have all your local minimum and local maximum x values that are separating you between increasing and decreasing intervals. All right, happy trails. There's number 16.